Hi, we're here with Brian Taylor from Schneider Electric Motion. Brian is going to tell us a little bit about some new developments in indexing and general industrial automation. Brian, what is it we have here?
What we have here, Lee, is the Lexium MDrive demo. We call it our Lexbox demo, and basically it breaks out all of the integrated capabilities of the product in a very user-friendly fashion. Specifically what we have here is a single stack version of our NEMA 23 fully programmable Lexium MDrive. And with this demonstration, specifically what we're trying to show is not only the capabilities of the motor from a drive integrated standpoint, but from a programmability standpoint. There's a full motion controller built into this device, and it also has programmable I/O points as well. We have 4 digital inputs, 1 analog input, and 3 outputs at our disposal. This box here actually shows the digital inputs that we have. The 2 outputs are on display with 2 green LEDs, and then we have 1 additional analog input, which is being shown by this potentiometer. I have a program stored right now inside this drive, which these inputs are tied to and exciting different types of motion based upon which input is selected. So if I were to toggle this first input, for instance, the motor is running at a predefined velocity in that portion of the program. If I turn this input off, and I actually excite input number 2, now we're actually running an indexing program where the motor oscillates out to a certain position in the positive direction, waits, and then rotates back to a certain position in the opposite direction. That's all predefined and stored inside the programmable controller on the drive. If I then use input number 3, I'm now actually commanding motion, actually a velocity profile, dictated by an analog voltage off of this potentiometer. So I can control the velocity by the analog input that's being sent into the programmable drive off this pot. What you may be noticing as well when we're actually toggling these switches is that you'll see we have these LEDs turning on and off based upon what's going on in the application. Those are 2 of the 3 outputs doing their job, and they were programmed inside the drive as well.
How much of a job is it to actually program an MDrive? What's involved?
Well, Lee, it's actually quite simple. Because I can do it and do it quite frequently, it's got to be simple. But basically it just involves downloading our user interface software from our website and launching that on your PC, and then connecting with a serial cable or an Ethernet cable, launching the software and then connecting to the device and starting your program from there.
And how much does the user or the programmer have to really know about creating a motion profile to do that?
You know, we've got a lot of example routines that are on our website for download, so we like to document heavy so folks aren't struggling so much out of the box. Any expertise in the motion world is always helpful. A little bit of a knowledge on acceleration, deceleration, velocity, and triangular and trapezoidal profiles is nice, but again, we have a lot of demonstrations programs that kind of take care of that for you, that are easily documented or well documented for the user.
Is there an upper limit on how big the program can be?
There is, although I've never reached it. I couldn't even begin to tell you what the actual capacity of a program for a single axis control like this would need to be to reach that upper limit. We've actually increased the storage capability in the Lexium MDrives from our older products, and working in applications for the past year, we've never come close to even touching the higher end of the memory spectrum.
When you're networking several of these together for a multi-axis system, how much complexity does that introduce into the programming?
It's a great question. So the best and easiest way I always recommend folks network our drives is actually over Ethernet. If it's a new application and they have the opportunity to select their communication protocol, we recommend typically that they use Ethernet. Ethernet's nice and clean, and we offer a lot of protocol options over Ethernet. We have Ethernet IP, which is a protocol mainly used by PLC manufacturers like Rockwell or Omron. We also have Profinet, which is another protocol over Ethernet that typically is used with Siemens products. We also have Modbus TCP/IP, which is another protocol over Ethernet that's very commonly used for HMI manufacturers as well as PLC manufacturers. So when you're networking, it's just as simple as addressing the unit with an IP address, a static IP address, And then on the host control side, making sure when you set up your communication modules that you know what that static IP address is and you know what communication protocol to talk to it with.